Hi, welcome back to the Calculus 3. And in this video, we are going to go over the assignment series. So we are going to practice some of the assignment problems in the worksheets. So we are still under the topics vectors and the geometry of space. So this is our second practice worksheet. So we talk about the vectors. So before you go work on these worksheets, I strongly recommend you to go back to review the lecture series, number 2. Remember the assignment number and the lecture series, they're always aligned here. So go back there to review the number 2 lecture series, number 2, talk about the vectors, and we did many problems in that videos here. So here, just as always, we're going to take a look at the number 2 assignment worksheet to see any problems like maybe harder and what we discuss in the lecture, and I'd like to do a couple or a few to show you how to work this. Okay, so I'm going to go to the worksheet page, and so let's start to work on the problems here, right? Okay, so like in here, okay, so for the first page is here, find the additions, subtractions, those things about the vectors. I'm pretty confident you should be able to know how to do it. And especially if you watch the videos, number 2 about lecture 2, you definitely should know how to do it. We did several examples there. So the first problem I want to do, and to show you how to do this here, it will be the problem number 6 here, okay? So the problem number 6, and we're going to find the vectors. And now for this given vectors, so like this vector have a specific length. So the length of this vector is 4, all right? And then they have the same directions, right? So like we talk about in the lecture series, if it's the same direction, that means if they are, the different only by a constant. So that means I need to find a way to see, okay, the vector I have has to have a length of the 4. So here. So the first thing is here, so if we can find a unit vector based on this given vector, then we times 4, it will give me the length of 4, right? So how to find the unit vectors here? So the first thing is here, you need to find what is the length of this vector 6, 2, and the -3, right? So this is we discussed in the lecture. So how do you find the length here? So you basically is like a 6, you squeeze, that's a Pythagorean series, right? Do you remember that? We talk about it in the lecture series. So this is -3, and then I got here it's 49. So square root of the 49, so it's equal to 7. So from what we did before, so I know the unit vectors here, right? So the unit vector will just be this vector divided by what? Divided by its length here, right? So it's 7, and this is -3 and the 7th, right? So this will be the unit vector. So now the same things here. If I want to have the vector with length equal to 4, then what you need to do? You need to times the constant, right? So if you just times the constants in front of this vector, so this vector will be the length of 4. Or some people, if you want, you can put this out 4, 7, then put the original vectors in here. So that will be easier to visualize. So it will have the same directions, and the length is 4, right? Because why? Because this is the unit vector here. Okay, so then the next question I like to show you how to do is, it will be the problem 32 here. Okay, so I'm giving you a little bit more space for the problem 32 here. Okay, so for the problem 32, and so let's see here. Let me see. I want to open the colors. Still the same color would be good. Okay, so now in here they said find the magnitude of the resultant force and the angle it makes with the positive x-axis, right? So I want to find the angle and the resultant force. So this is one of the force, this is another of the force, right? So this force, these directions, the force applied to this direction is 20 pounds and with 45 degrees. So, from the basic physics, we know the force you can separate it out as the horizontal and verticals, right? So in here, so for here, if you put this into okay, so like these triangle, these right angles, right? So now you see here, this force here, right? So the horizontal, okay, so the horizontal is the x direction force and y direction, right? So what is the x direction force here? So this will be the 20 what? Cosine 45, correct? Because it's the hypotenuse time, adjacent over hypotenuse cosine 45, right? So that's why the horizontal one, the x level force will be 20 cosine 45. So the same way, so for the vertical, the y direction force for this one is sine 45 degrees. So as you can see, for this force, I can break it out in the x direction and the y directions, right? Okay, so now, then the next one's here. So for this force here, I can do the same way. Okay, so this one's here, right? It will be, I also can have what? The x direction and y directions, right? So x directions here. So if you take a look at the, the right angles here. So x direction is what? Is the hypotenuse times what? Cosine. So there is a cosine 30 degrees here. And because it's x direction, then the y direction, because it is going, is on the negative side. So the y directions here, it will be the negative 16 sine 30 degrees, right? So this is what this is what we have to break out, the vector as from the physics point of the force. So we have x direction force and y direction force. So if you put it into your calculator, so this one's here will give you is 10 square roots of the 2. This is 10 square roots of the 2 here. And this one's here, if you break it out, this one will give you a square roots of the 3 and negative 8. Okay, so what is the resulting force here? So the resulting force will just be, you add these twos, right? So the resulting force will just be the 10 square roots of the 2 and the 10 square roots of the 2 plus a square roots of the 3 negative 8, correct? Okay, so now in here, you can just so this will be the 10 square roots of the 2 plus a square roots of the 3. And this is 10 square roots of 2 minus 8, right? So if you put it into your calculator, you can get about, this is 28. And then the other ones here is 6.14. Okay, so you put it into a calculator. So the resulting force, right? So if I say this is the force F here, right? So I have two directions here. So the magnitude of the force will be just the length of that. So what is here? The Pythagorean theory again. So it's 28 to the square plus 6.14 to the square. So what do we got here? So we got is about so it's very close to 28.7. So this is the magnitude of the force, right? Okay, so this is the magnitude of the force. Then the tangents, right? So the tangent, so the thetas here, so they want you to find the angles, right? So that means I know then the tangent theta is equal to what? So this is the x direct. So this is x, this is y, right? So tangent is the opposite over adjacent, right? So here there will be the 10 of the square roots of the 2 minus 8 and over 10 of the square roots of 2 plus a square roots of 3. So it's like a 6.14 over 28. So then you use the tangent, you will get the theta is about 12.4 degrees here. So that means your resulting force, right? So your resulting force will be something like in here, right? So like, right? So this angles here, this red angles here is 12.4 degrees. All right, so this is the first kind of the physics type of the application problem. That's why I like to do this problem to show you how to, use the vector concept, right, to apply it to the physics application. Okay, so now the remaining will be pretty, I think you'll be able to do that. And now I want to do one more application problem to show you, and this one is a little bit complicated, but I like to show you how to solve it so that you'll be able to solve the remaining ones here, right? Okay, so now let me go back to get the, okay, so this is the blue lines here. Okay, so you have something heavy hanging there, right? So you have two ropes, it's 2 meter and 3 meters ropes here. Then this is the total weight is 350 Newton. And the rope is kind of tight. So the first rope, you have like an angle 50 degrees. The second rope, you have an angle like 38 degrees here. Okay, so now I want to find the tension of each ropes here. All right, so I want to find the tension of each ropes here. So I will see the tension. So this I have a T2. So this one's here. So this is the tension. So this is the tension for the 2 meter rope, right? Okay. And then I have a T3. So this is the tension for the 3 meters rope. So let's make sure our notations is good. So now in here, okay, so if you do like, I think here, if you put these things in the coordinates plane. So basically, this heavy thing, 300 newtons, is sitting here, now moving. That means you have a what? You have a force here. You have a force pulling it up, right? You have a force pulling it up, and this force here is 350. So then your 2 ropes is tension, right? So the ropes is tension is here, but they do have X direction, Y directions, right? So this is the overall force pulling that up, correct? And then you have the T2 and the T3s, right? So now in here, so let's say here, so then you know the T2 tension plus the T3 tensions, right? So these 2 ropes will be 350 newtons here, because this is the, so this is the tensions here and here, so right, so this is one of the, and this is another ones, right? So then, because this thing's not moving, so I know the T2 plus T3 is balanced, right? So they counterbalance each other, so that's why it's 0, and the whole thing is pulling that up. All right. Okay, so now let's take a look. How do we solve it, right? So I know the T2 plus T3 is 0 to the 350s here. Okay, so now the T2s, right? So I need to find the T2 and T3s here. So now the tensions here is T2 and the T3. So, okay, so for here, so for the first coordinates here, that's the X coordinates, right? So I know this will be the negative. Whatever the T2s is, then the cosine 50, right, plus T3 cosine 38 is equal to 0, right? Because this is 50s, right? Got it, right? So the whole thing is these ropes here, this is tension number 2. So, like in here, the horizontal, so take a look, this is the horizontal part, that's the X direction part, right? The reason why these ones here got a negative because it's go to this way, the left-hand side. So like I say, if you put a coordinates, this is negative. So that's why this one's here will be what? So it's the tension of the T2, right? So the tension is here. This is what we say is T2 tension, and this is T3, right? So the x directions will be the hypotenuse and the times the cosine 50, but it's because it is on the left-hand side of the origin, so it's negative. And the T3 is here, that is the horizontal force, the tension, right? So that's where this angle is 38. So that's why the horizontal is T3 cosine 38, because this, they balance, not moving, so that's why they add up to zeros here. Okay, so now let's take a look at the other one, the vertical one. The vertical one, it will be T2s, right? So T2, now here, what is the vertical one? It's sine 50. So both of them is going up, so it's both of positive. Then plus T3, then this is sine what? 38. Right, so this horizontal tension when you add this vertical tension when you add them up is what? This is 350. So basically, you have two equations. You want to solve two variables. So you want to solve T2, T3s, right? Okay, so now from the first equations here, I can get just from algebra, I know that T2 is equal to what? T2 is equal to T3, and this is a cosine 38, right? And this is a cosine 50. Good? Okay, so now you plug this T2 back to here, back to the second equation. So the T2, this is T3, and cosine 38, cosine 50 times sine 50 plus T3 sine 38 and equal to 350 here. All right, so now in here, okay, so this one's here, cosine sine, if you want, you can change this is to the tangent 50s here. All right, so now let's go to here. Okay, so now how do I solve T3? Okay, so you can factor the T3 out. So the T3 will be equal to what? Will be equal to 350s, right? So this is 350. And what is the bottom here? The bottom will be the cosine 38 tangent 50 plus sine 38. Ta-da, I got it, right? So this is T3. I have a 225 if you put it into the calculator, 11 Newton. Okay, after you got a T3, then I can put it into a T2. So the magnitude of the T2 will be 225.11 times the cosine 38 and the cosine 50. And you will get this is 275.974. Okay, so this is the magnitude of that rope, right? So now I can break it down to the two. So now I can write it up. So now I know the tension for the T2, it will be what? So the T2, this will be negative, the magnitude times what? Cosine 50. And this will be the T2 times the sine 50s, right? Okay, and then the T3 is the same thing. So T3 will be the magnitude times the cosine, what? 38. And then this is T3, the sine 38. All right, and now you can, so now in here you can plug the value we just get, and then you can get here the T2's tension is negative 177.39 and 211.41. All right, then the T3 is here. It will be, I hope my calculation is correct, 17739, and this is 138.5. 5 nines here, right? So that's why that's why they said find the tension each row, right? So the tension is a vector because the tension doesn't have the horizontal fact, have a horizontal and the vertical components of it, right? So as you can see, this kind of makes sense, right? So because that's why the horizontal, the x direction cancel out. That's why the metal, since the hanging layer is not moving around, right? All right, so I guess that's it. And so the remaining problems, I think you should be able to handle that. And this one, I think, personally think this is probably the pretty hard work problem, the word problems in this assignment sheets. And I'm kind of have a confidence you should be able to finish the number 30A and 40. All right, so I think those, we did 3 problems in this assignment. And so your job is to complete all the remaining problems on these worksheets. So remember, you need to practice and then you will remember, right? So try to finish the remaining problems, and then those 3 problems hopefully can help you to understand the better concept and how to apply it. All right, and that's it. And it's nice to talk to you on our second assignment. So looking forward to our next lectures, and then we'll work more problems on the next lectures. Okay, so you guys have a good day, and I'm looking forward to talk to you in our next lecture number 3 here. Okay, bye.